Small businesses often have just one employee who can serve customers when they arrive. In this movie, I will demonstrate how to analyze a queue at a pharmacy that has one person serving customers. My sample file is Chapter 3, Movie 1, Queue with One Server, and you can find that in the folder included with the movies for this course. I have 3 pieces of information. One is the number of servers, which technically isn't necessary, but I included it to remain consistent with what I've done throughout the course. And then I have in B4 the arrival interval in minutes, and in B7 average service time in minutes. We'll start by calculating the arrivals per hour. So I'll go to B5 equal, and that will be 60 divided by B4 and enter. So 7.5 per hour. And because I've covered this material already in Chapter 1, I'm going to be moving a little bit more quickly and explaining a little bit less. The arrival rate is 1 over the arrival interval in minutes, and it can be very easy to forget and divide by arrivals per hour. In fact, this is time, not a count, so we're looking at the arrival interval in minutes. So in B6, I'll type equal 1 divided by B4 and enter, and we get a rate of 0.125. Now we can do similar calculations for customers served per hour. So in B8, I'll do equal 60 divided by the average service time in minutes. That's in B7. Enter. We get 20. And for the service rate, it'll be 1 over the average service time. So 1 over B7 and enter. And we get 0.3 repeating. And now the utilization will be our arrival rate, or lambda, divided by the service rate, mu. So in B10, that will be equal to B6 divided by B9 and enter, and we get a utilization of 0.375. With those base calculations in place, we can now work with the last 4 characteristics or calculations that we will use to summarize the system. The average queue length is the utilization squared divided by 1 minus the utilization. So in B11, I'll type equal, and that will be B10 squared, so Curt 2 divided by the quantity of 1 minus the utilization again in B10, and enter, and get an average queue length of 0.225. The average number of customers in the system is a similar calculation, except we won't square the utilization at the top. We'll just use it on its own. So equal B10 divided by the quantity of 1 minus B10, again, 1 minus the utilization, enter, and we get 0.6. Now for the average time in the queue, we will divide the average queue length by the arrival rate. So that will be in cell B13 equal B11, that's the average queue length, divided by the arrival rate, or lambda, in B6, and enter, and we get 1.8 minutes. So that's pretty good. We have an average service time of 3, and they wait a little more than half that on average. That's not too bad. The total for the average time in the system will be the service time plus the time in the queue. So in B14, I'll have equal B7, average service time in minutes, plus B13, the average time in the queue, and enter, and we get an average time in the system of 4.8. So as you can see, we have very low utilization, which means that we have a very efficient system, and we get our customers through very quickly. In the previous movie, we looked at modeling queues at a pharmacy with just one person serving customers. In this movie, we'll see how the queue's performance changes when, instead of 1 server, there are 3. The formulas to calculate the average length of the queue are very long, so I've entered them for you. My sample file is Chapter 3, Movie 2, Queue with Multiple Servers, and you can find it in the folder with the remainder of the files for this course. I have left in the calculations for the previous movie, that is the single server case on the left, and I've also copied over any formulas that also applied to this case, so that goes down to the service rate. We've done those calculations several times in this course, including in the most recent movie, so I figure if you need to look them up, you can. The first change we need to make is in how utilization is calculated. So I'll go to cell E10. And for multiple servers, we multiply the number of servers and the customers served per hour. So in E10, I have an equal sign. And then lambda is our first term, so that is in E6, the arrival rate, divided by the quantity of the number of servers in E3, multiplied by the service rate, or mu, in E9, and enter and return, and we get utilization of 0.125. We have 3 servers, and I see that the utilization for the single server case was 0.375, so dividing that by 3 makes sense. We go down to 0.125. Now we can calculate the probability that there are 0 individuals in the queue, and that will feed into the average queue length calculation below. So I'm going to scroll to the right, and I have started entering the support calculations. There are 3 servers, so I need to do my calculations for the values 0, 1, and 2. That's the summation of n from 0 to s minus 1. So from 0 to the number of servers minus 1. The calculation, which I have created for you, is in cell H3. So I will double-click that cell and backspace to delete the single quote that I used to render this formula as text, and enter, and we get the support calculation value of just over 1. And again, this doesn't actually mean anything. It's just a support to get us to the value that we want. Now I will select cells G3 and H3, and I will copy down twice, so we get the values for 1 and 2. So I'll drag the fill handle, and there are the values for 0, 1, and 2. And as part of the calculation, I need to find the sum of those 3 intermediate values. So in H6, I'll type alt equal, sum of H3 to H5, and enter, and there is the total of those 3 of 1.468. Then I'll go to cell E11, and the probability that there are 0 in the queue is 1 over the value from H6. So equal 1 divided by H6 and H6. There we go. There's a cell reference, and enter. And we get a probability there are 0 people in the queue of 0.68. So as you can see, with 3 people handling a fairly low volume, we have an average queue length, or rather a probability there are 0 people in the queue, that is quite high. Now the average queue length depends on the value that I just entered in other parts of the worksheet. And again, I've entered this formula for you. So I will double click E12 and backspace over the single quote and enter. And we get an average queue length that is very, very low. If we want to calculate the average number of customers in the system for the multiple user case, then I will add the average queue length and the utilization. So in E13, I'll type equal. That will be the average queue length in E12 plus utilization in E10, and enter. So again, a very low number of average customers in the system. And then the average time in the queue, which we are calculating in cell E14, is going to be the average queue length divided by the arrival rate. So that will be equal E12, the average queue length, divided by the arrival rate, or lambda. That's in E6, and enter. So we have very short waits. In fact, most customers that come through won't wait at all. And the average time in the system is the average service time plus the average time in the queue. So that will be E7 plus E14, and enter. And for an average of 3 minutes of service, we have an average time in the system of just a little bit over that. So what this means is that we have a very efficient system, and you might wonder where this sort of thing might happen. Well, if you have a pharmacy that mostly does service for doctor's offices and isn't popular among patients, then you would have this type of system. You have 3 servers who are ready and willing to handle customers, but they spend most of the time in the back filling orders. So while you won't find this sort of setup very often because there will typically be fewer servers available, it's not impossible that you will see this sort of efficiency and very low utilization in a system such as a pharmacy. One of the classic models for a business where customers queue up for service is a sandwich shop with a single employee. In this movie, I will show you how to model a shop with a single server by looking at 20 customers. My sample file is Chapter 3, Movie 3, and I look at a sandwich shop with one station, and in this case, one station means one server. I'll start by creating a table that we can use to look up random arrival times, and in cell A2, I have the average arrival gap, and I'll use that as the basis for the calculations. In cells A5 and B5, I will enter a 0, and that'll be the first row of the lookup table. And now in A6, I'll type 1. So this will refer to the probability of getting an arrival gap of 1 or less. So in cell B6, I'll type equal, and we'll use the Poisson distribution. So Poisson.dist, and x is the value in A6. The mean is the value in A2. A6 I want to vary because I will have the probability for different arrival gaps, but A2 I don't want to change. So I'll make that an absolute reference by pressing F4, then a comma, and I do want the cumulative probability, so I will press Tab while true is highlighted, right parentheses and enter, and I get the probability of 1 or less of 0.04. Now I will copy the values from A6 and B6 down until I get close to 1 with the probabilities, and I will go ahead and grab the fill handle and drag down to row 24, and I think that will be good. I have values, arrival gaps going up to 19. So I will edit cell B24 so that instead of the values that I see there, I'll just make it 1. So the lowest I can have is 1, the way that I'll create my lookup formula, and the highest will be 19. Now we can do the same thing, or a similar thing, for service time. I'm going to be using the exponential distribution. So in cell E2, I need to get 1 over the average service time. That will be the lambda for the exponential distribution calculation. So in E2 equal 1 divided by D2. Enter, and there we go. Now I can start my service times at 1. So in D5, I'll type a 1, then tab, and the probability will be based on the exponential distribution. So in E5, I'll type equal exponent.dist, and then x again is the value in D5. That's the service time we want to compare. Then a comma. The lambda is in E2, and I don't want that reference to change, so I will press F4 to make it an absolute reference, then a comma, and I do want it to be cumulative, so I will press Tab when true is highlighted, right parentheses and enter, and there we go. The probability of a service time 1, given the average is 3, is 0.28, so about 28% of the time. Now I can copy these values down, so I'll select D5 and E5 and drag the fill handle at the bottom of the right corner down to cover row 24. And let's say that the longest service time that I have ever observed was 20 minutes. So I will click cell E24, type a 1 and enter, and there we go. So my lookup for service time can go from 1 to 20, and for the arrival gap, it can go from 1 to 19. With all that set up in place, we can go over and start creating our table, which will give us results for each customer. So I will start with a row of zeros, and that will give us values that our formulas can use instead of trying to work with text cells. So with G2 to N2 selected, I'll type a 0, then Control Enter. That puts a 0 in every cell. Now I'll start with customer number 1, and the arrival gap will be a lookup based on a random value generated between 0 and 1 inclusive, and it'll be a decimal number. So in H3, it's equal XLOOKUP. The lookup value will be the random value between 0 and 1, and then a comma. The lookup array will be in column B from B5 through B24. I don't want that reference to change when I copy the formula down, so I'll press F4 to make it an absolute reference, then a comma. The return array is the actual arrival gap, and that's in column A next to it, A5 through A24. Again, F4 to make it absolute. Then a comma. Don't need to worry about if not found, so comma again. And match mode will be exact match or next larger item, so that's 1, right parentheses, and tab. And there we get our arrival gap of 3. Yours will probably be different. And also, depending on how I have to edit this video with mistakes that I make, you might see my random values for arrival gap or service time changing. Don't worry about that. It's just a fact of the editing. I'll try to call it out, but if you see it, don't worry about it. It's not you, it's me. Now, the arrival time will be the previous customer's arrival time plus the current customer's arrival gap. So in I3, I'll type equal I2, that's the previous arrival time, and that's why we put zeros in the first row, plus the arrival gap for the current customer, that's H3, tab, and then the arrival gap changed in this case to 7, and arrival time to 7 as expected. The start time is going to be the later of this customer's arrival time and the end of the previous customer's service. So that will be in cell J3 equal the max of I3, comma, and then the previous customer's end time, so that will be in L2 plus 1, because we assume it takes a minute for the server to reset and be ready to accept a new customer. So there's a right parentheses and tab, and there we go. We will look up the service time by looking at the table that we created earlier in columns D and E. So in cell K3, I'll type equal, and this will be, again, XLOOKUP, and then the random value, a decimal value between 0 and 1, so rand open and close parentheses, then a comma. The lookup array will be in E5 through E24. I don't want that changing, so I will press F4 to make it an absolute reference, then a comma, return array. Same thing, just in column D. Then comma, don't need to worry about not finding it, comma, exact match or next larger, then right parentheses and tab, and we get a service time, in this case of 5. End time will be the start time plus the service time, so in L3 that's equal to J3 plus K3 and tab. The wait time will be the start time minus the arrival time, so in M3 that will be equal to J3 minus I3, and then tab. And the total time is end time minus arrival time. So in N3, that will be equal L3 minus I3. So again, we're including the wait time in this calculation, and enter. All right, there we go. So now, to create records for 20 customers, I can select cells G3 through N3, and then drag down to cover row 22 because I want 20 customer records. There we go. And you can see that I have very low wait times, very low, or at least average service times, and no customer has to wait more than 6 minutes, and that's early in the day, but we were able to catch up. Now I can create my summary formulas. And this is one of those occasions where I edited the worksheet, so you'll see different values from when I created the table. But you can see that the values aren't really all that different. The one difference is that we have a wait time of 12, but everything else looks pretty good. The backlog cleared out pretty quickly. Now we can create our summaries. So I have created headers for those down in column E, starting in row 27. And let's say that we want to find the total wait time. In cell E27, I'll type equal. That will be sum M3 to M22. That's the wait time column, and enter. So we get total wait time in this case of 2:36. The average arrival gap in E28, so that'll be equal average H3 to H22, enter, and that goes down to, or rather is 6.4. The average wait time in E29 will be equal average M3 to M22. So we have our average and total wait times. And total time in the system will be the maximum of column L, which is our end time for individual customers. So that'll be equal to max of L3 to L22, and enter. Then the average service time in E31 is equal to average K3 to K22, and enter. And then the average total time for each customer will come from column N. So that would be equal average N3 to N22, and enter. So in this most recent run, we have total wait time of 32, average arrival gap of 5, and the other values that you see there. If you want to run multiple simulations for 20 customers, you can press F9 to recalculate. See, the total wait time went up significantly. Down to 34, up to 240, that's significant. So if we scroll up, we can look at where it started getting bad. So our total wait time started when we had 2 customers that arrived very close to each other with one, and we had a high service time. Actually, we had 2 high service times in a row. So we had 2 8s, and then you can see that the wait gets really bad at the end because we had a service time of 13. And if I look at the service time table, I see that happens less than 1.5% of the time, but when it's combined with other long service times, then you can get some very long waits. One of the experiences all conference attendees have in common is waiting in line to get your badge. In this movie, I will assume there is actually a 2-step process to get your badge, and then to stand in another line to pick up the bag of free items that are provided by the conference's sponsors. I will use a simulation table to model this process, and the file I will use is Chapter 3, Movie 4, Conference Check-In 2 Stations. I have already done a fair number of calculations for you, just to save time, because this will be a fairly long movie. So I have for our customers an average arrival gap of 4. So for this part of the process, an individual will arrive on average about every 4 minutes. And I have the probabilities calculated for arrival gaps from 0 to 19 minutes. And I assume that 19 will be the worst gap that we will ever see. The probabilities are calculated using the Poisson distribution, which is exponential and is used to estimate or model the typical gaps between events. Then for service time, I have the average service time of 2, so it takes 2 minutes to help a customer on average. We're going to use the exponential distribution. So for that, we need 1 over the average service time. So that is calculated for station 1 in cell E2. Below that, I have a model of service times going from 1 to 20 minutes, and you can see here that I use the exponential distribution. For station 2, I have that set up down below, and I have an average service time of 4. There is 1 over average service time, and I have a similar table set up for station 2 as for station 1, except that because the average service time is higher at 4 minutes, then I have the range going from 1 to 24 instead of only up to 20. With all that in place, I can scroll to the right and start creating the table. I've already put in the table labels. Those start with the number of the customer, then the customer's arrival gap, and then we will calculate from that their arrival time, start time for station 1, service time for station 1, end time for station 1, and wait time for station 1. Then we will do the same thing for station 2, and I've abbreviated the labels to save space. Then we have the total time in the system, total service time, and total wait time. So I will go ahead and start by selecting cells G6 through T6, and to make it easier to use our formulas, I'll type in a 0 in G6, and with the cell still selected, press Control-Enter. Using Control-Enter that way puts the same value or formula into every selected cell. Now we can start with customer number 1. So in G7, I'll type a 1, then tab. Then in cell H7, we need to calculate the arrival gap. So I'll type equal, and this will be an XLOOKUP. And the lookup value will be a random number, a decimal between 0 and 1. So that is rand, and then open and close parentheses. The lookup array is B5 through B24. So B5, and then F4 to make that absolute, colon, B24, F4 again, then a comma. And the return array will be one column over, so that'll be A5, and again F4, colon, A24, F4. We don't need to worry if the value is not found. We have completely taken care of all possibilities, so I will leave this blank and type another comma, and we want an exact match or next larger item. So that'll be a 1, and right parentheses close, and tab. You will probably see a different random value than 3, but don't worry. And also, as I go through this, if I have to make edits, it's possible that the worksheet will recalculate every time I do. So if the values seem to change for no reason, it's because I made a mistake and I had to go back and cut something out. So don't worry about it. The arrival time for a customer is the arrival time of the previous customer plus the arrival gap. So in I7, that is I6, the previous customer's arrival time, plus H7 and tab. Then a customer start time will be the later of when they arrive or 1 minute past when the previous customer's service ended. So we assume that it will take the server at least 1 minute to reset between customers. So in J7, I'll type equal, and it will be the max of I7, which is the arrival time, then a comma, and 1 plus the previous customer's end time, and that is in column L. So it will be L6 plus 1, right parentheses, and tab. The service time is another randomly generated value. So this will be service time 1, and that data is in columns D and E. So in K7, I'll type equal, and it's another XLOOKUP, and it will be, again, a random decimal between 0 and 1, so rand, open and close parentheses, comma, and then the range of E5, F4 to make it absolute, to E24, F4 again, then a comma. The return array is one column to the left, so that's D5, F4 for absolute, colon, D24, F4 again, comma, don't need to worry if it's not found, so comma again, and match mode once again will be 1, exact or next larger. Right parentheses and tab, and we have our end time next. The end time will be the start time plus the service time, so that is just equal, J7 plus K7 and tab, and there we go, start time of 5, service time of 4, end time of 9, so that's correct. And wait time will be the start time minus the arrival time. And because we didn't have a customer in the queue before, it will be 0, but it will change as we go along. So in M7, I'll type equal, J7, the start time, minus I7, the arrival time, and tab, and as expected, it's 0. Now we move on to station 2. So for N7, we need the start time for station 2, and that will be 1 plus the customer's end time for station 1. We assume it takes a minute to move from one station to the other, or 1 plus the previous customer's end time at station 2. So it's basically the same thing as we did for station 1, just moved over a couple of columns. So in N7, I'll type equal, max again, and then inside the parentheses, it'll be L7, end time for station 1, plus 1 to account for the transition, then a comma, and then the end time for the previous customer at station 2. So that will be P6 plus 1. Again, we add a minute. Right parentheses and tab, and we're starting at station 2, 1 tick after we ended at station 1. Now we need to randomly generate the service time for this particular customer at station 2. So in 07, I'll type equal, and again, it's an XLOOKUP. So XLOOKUP, and then rand with open and close parentheses, then a comma. The lookup array will be from B30 and F4 to make it absolute, colon, B54, and F4 again, then a comma, and the lookup will be one column to the left, so that's A30, F4 again, colon, A54, F4 to make absolute, comma, don't need to worry if it's not found, it will be, then a comma, and 1 for exact match or larger, right parentheses, and tab. Okay, we're getting close to the end, and I know this has been a lot of work. Now in P7, we have the end time for station 2, so that's equal the start time, which is in N7, plus the service time, which is in 07, then tab. Very good. And wait time for the second station in column Q is N7, so equal N7. That is the start time, minus L7, which is the end time for station 1. But because we had a minute of transition, I don't want to consider that a wait for these purposes. So I will subtract 1. You can choose to include it and not minus the 1, but I'm doing it in this case. And tab. Now the total time in R is the end time at station 2 minus the arrival time back in column I. So in R7, that'll be equal to P7 minus I7. Yep, total time is end time 2 minus arrival time, and tab. Very good. Total service time is just the two service times added together, so equal service time for station 1 is K7, plus service time for station 2 is 07, and tab. And the total wait time is very similar. It's just the total of our two waits. So in T7 equal, that will be M7, wait time 1 plus Q7, wait time 2, and enter. Great. So there we have all of our values for the first customer. And now I can select cells G7 through T7 and drag the fill handle down until I cover row 26. So that gives us 20 customers, and I have my randomly generated values. So the arrival gaps look pretty good, and the service times for station 1 are quite low except for an 8. And then on station 2, we have an 11 for a service time and a 12 right at the very end. However, if I look at the total wait times, then it doesn't start to add up until the end of this 20 customer sequence. And I can see that is because I had some fairly high service times that we weren't able to clear. So we had the 9 and the 8 for service at station number 2. If I want to calculate new values and generate a different scenario, I can press F9, and there I see I get some very large total wait times. Press it again, a fair amount of high waits, and again, and again, and again. So what it appears is that the system as I have it set up leads to customers typically having to wait quite a bit. So what I'd rather do is add more resources to reduce the processing time at each station so I can get the conference attendees through more quickly. Defining a model of a process or queue gives you a tool you need to analyze it and identify possible improvements. In this movie, I'll describe some ways that you can look at your data to discover why your process works, or more possibly, why it doesn't. First, we'll look at queues. One of the best ways to analyze a queue is to look for utilizations that are approaching 80%. And this is the reason. The closer you get to 100% utilization, the more the estimated wait time increases. The estimated wait for each customer goes up. However, when you get closer to 90 or 95%, you see a very sharp increase. And that's because those waits increase because of the randomness of arrivals. So try to keep your utilizations at 80% or so, and if it's higher, then start looking for ways to increase the amount of resources that you apply to that queue. Next, you can create multiple queues with variable service speed. You can use the techniques that I showed you in this course to create different parts of a single worksheet, or you can model different queues across worksheets and then consolidate the results into a dashboard. And finally, you can ask if wait times are reasonable. Is making someone wait 5 minutes for a 10-minute appointment okay? And if so, how about making them wait 15? This all depends on your business model and what you know about your customers. Now let's take a look at processes. First, ask what makes wait times increase and how you can solve those problems. For example, do certain requests always take more or less time? If you can identify those that do, then perhaps you could bring in a supervisor to handle those requests while the frontline employee handles the next request that comes along. A related question is whether certain customers always take more or less time. In retail, we all know that some individuals just enjoy hearing themselves talk, and they want to have maximum engagement with your frontline employees, and it can make sense for a store manager or another supervisor to take over and give them what they want so that they can free up other resources within the system. These are just some questions you can ask. I encourage you to use the techniques that you've seen in this course to create different scenarios, look at different assumptions about your system, and see what you can learn and improve your business. Thanks again for joining me in the course. I wanted to give you some ideas for next steps so that you can further your knowledge on queues and processes and on related topics. I have an entire set of LinkedIn Learning courses that are available to you. So if you have a LinkedIn Learning subscription, perhaps it's available through your business, through your college or university, or your local library, or you subscribe personally, you can look for courses by me on Excel data analysis, what-if analysis, and then supply chain analysis, managing simulations using VBA, and also value stream mapping, which is terrific for laying out a process on paper and seeing how it works. And finally, Excel VBA process modeling. I'd especially encourage you to look at the 2 VBA courses because they give you the programming tools that you can use to automate some of the analysis techniques that I showed you in this course. There are also 3 books that I recommend. The first one is Optimizing Patient Flow. It was edited by Eugene Litvak. And that book, although it's specific to the medical field, provides great insight and analysis and also formulas that you can use to analyze patient flow. A more advanced text is Probability Markov Chains, Queues, and Simulation. That's by William Stewart from Princeton University Press. And this is an academic book. It's a textbook, but what it does is it gives you a little bit deeper of an understanding of what's going on with the techniques that I showed you here. And finally, a book that I recommend whenever I can, and that is Microsoft Excel 365 Data Analysis and Business Modeling. It's created by Wayne Winston, published by Microsoft Press, and it gives you an amazing array of techniques that you can use in Excel to analyze your data and, as it says, model your businesses. Between these 3 books and the LinkedIn Learning courses that I mentioned earlier, you will have an amazing portfolio of techniques and knowledge that you can apply to your own business processes.